Welcome back, everybody. It's your boy Chef, and this is lesson 2 on our journey to create a game in Unity. In the previous video, I showed you how to move an object, and then you can also rotate the objects. And if your object can be scaled, then you can use these keys to scale the object. Okay. Today, I'm going to show you, actually we're going to get a little bit into writing code and how to use something here called the console. So let's get going here. But first, we got to make sure that everything is all square. I said that you'll want to get Visual Studio 2017. Make sure you have that installed. And then in Unity, come up here and push the edit button. And we want to go down, where do we want to go? Yes, we want preferences, okay? And from preferences, we want to look at the external tools, okay? And then external script editor. And you want to make sure you have Visual Studio 2017 chosen. Okay. All right. If needed, you can hit the browse button. Okay. And you can find the Visual Studio application in your file browser and then choose it. Okay. Cool. So make sure it says Visual Studio 2017 up here. We now want to click on something called Project. Okay. And we want to go to Scripts. Actually, you probably, you don't have a Scripts folder yet. And I'm going to delete mine. Don't worry, it'll all make sense. Okay, so goodbye there. Great. And you know what? We don't have, well, you don't have this Procore yet. I'll show you what Procore is soon, but you should only have you might actually, in fact, should actually just have assets here, and then scenes. Okay. Well, we want to make a new folder. Okay. So with assets selected, we want to right click. We want to hit create. We want to create a folder. Okay. And there's our new folder, and I'm going to call it scripts. Okay. A script, not like a script in a play. No, a script is a line of code. And you can give scripts to various game objects. Okay. Good. I want to double click on scripts and open it. It's empty. And we're going to right click and hit create. And we're going to make a CSharp script. And then it's called new behavior. And we're going to rename it. We're going to rename it EXP. Okay. Short for experiments. Cool. And so when you select a script, the inspector will show this. This is actually the code that the script is going to run. Right now, there's not a whole lot in there. And what the heck? How do I write on it and edit it? Oh, no, don't fret. What you want to do, double click on your script. And that'll open Visual Studio for you. How's everyone's day going? I tried applying for a few jobs today. Didn't go too well. See, apparently it's kind of frowned upon to just go to a game studio and say, hey, I'm here about the level design position that I saw online. Anyway, get back to that later. So you're going to see something like this when Visual Studio finally opens. Okay. Don't worry too much about all of this. You don't really want to touch any of this up here. Okay. What we care about is everything that starts with the word public class. Okay. Before we start writing anything, it's very important that when you write in code, you must be very careful with your spelling of terminology and with your use of punctuation marks, such as colons, brackets, and parentheses. Okay. We're going to be writing in the C# language, and C# is the only type of code that Unity can work with currently. There are many other coding languages out there, and from what I hear, if you know C#, then it's pretty easy to learn C+ or CS, and other types of scripts. So we're going to go with C#. Yeah, this down here, that's not a hashtag. No, that's the sharp symbol in music, and so it's called C#. I don't know how it got its name. I'm not here to talk about that. A few things to go over here. Public class. Public refers to that this script can be accessed and used by any object that tries to talk to it. I could change it to private if I want. Okay. And now I have a private script, and this would prevent other objects from communicating with it, but we don't want it to be private. No, we want it to remain public. Okay. Class. Well, that's actually this code, this line of code. It's called a class. Okay. This is the name of the script that we gave to our new code. Okay. EXP. Okay. An important thing about the name. Let's say I want to change it. I want to actually spell out the entire word experiment. Okay, and I do that. And now I have a colon here, and we have something called mono behavior. Okay, mono behavior. This refers. This is essentially just the base type of code that all codes from Unity will derive from it. They're called mono behavior. But let's get back to this thing about experiment. Okay, I call it experiment here, and then we see that this little thing turns yellow. That just means that these changes have not yet been saved. I also have a light bulb here. Okay, a light bulb may offer some ideas of what I should do to make changes that could help me streamline my coding. So that's what's great about Visual Studio. If you're just using the notepad to write all of this code, you're not going to get any of these changing colors. You're not going to get this warning to save or these suggestions. So Visual Studio provides that for you. It does all this color changing for you automatically, and different colors indicate different functionality and different, etc. So we called it experiment, and this little bar turns yellow, and that just means I want to come up here and hit the save button. There we go. Now it turns green, and that means everything has been saved. Oh, well, okay then. Well, now we're going to try and hit play. We haven't really done anything to our script except change the name. If I hit play, things go all right. I have a little character dude there. Okay. But why don't we give our script to my character, and we get an error screen. Can't add script component exp because the script class cannot be found. Make sure there are no compile errors and that the file name and class name match. This part right here. This is the error. See, we went into Visual Studio and changed the name to experiment. However, the file is called exp. Unity doesn't like that. No, it's not very happy with us, and so it doesn't let us add the script on. Okay, and there's an easy fix. Just make sure that the file name and the class name match, and of course it turns yellow again. So make sure you hit your save button. Good. Now let's see. Now I should be able to put my code onto my character, and there we go. now my character has the code on it, and when we start to add some functionality into this code, we can hopefully get my little character here to move. Don't worry about the character shape and how to make that guy. I'll get into all that with you. But let's talk about working inside the Visual Studio for now. Now you might notice here that I added 2 scripts to my character. I don't want that. Okay, I can right click and I can remove component. It's usually bad practice to have the same exact script attached to the same object. You may slow down and your game may slow down and you may run into some performance issues. So make sure you don't do that. No duplicates. Okay. And yes, be patient. I will show you how to make this guy right here soon. Let's go back into our code. Let's try to do something. I spoke about this console here. We're going to try and get a message to appear on the console. Okay. All right. Going down my line, now we have these green slashes here. These 2 green slashes indicate that the programmer simply wants to leave a note for themselves, right? So the 2 green slashes use this for initialization. Anything on line 7 that follows these 2 slashes will not be read by Unity. They will be skipped over. These are just notes for the program. I could say whatever I want here. Okay, I'm going to actually, in fact, say this is just a note. Okay, and I don't get any errors down here, compiler mistakes. If I misspell the word note to not, nothing, right? Just a note. That's all. Okay. It has no bearing on what your code will do. And Visual Studio, being a very smart application, as soon as it sees the 2 slashes, automatically everything after the slashes will turn green so that the programmer can quickly and easily identify the notes in the code. Now, it still wants me to save it, though. So I'm going to do that. Okay. All right, moving down to line 8. Void start parentheses bracket. Well, let's talk about everything here. Okay. Void. Okay. This is what my code is going to return. And void means it's not going to really return any kind of information. We're not going to go anywhere. Okay. Start suggests that this line of code is going to run once and only once, and that is at the very beginning. As soon as I hit this play button here, anything that appears under the word start is going to run right away. This is very useful if you're, you reset a level and you need objects to be in certain locations. So let's say you're trying to complete some kind of first-person shooter and there are enemies to defeat, but then you lose at the end. Well, when you reset, you want those enemies to all respawn. Okay. Void start could help you get all of those characters back to their correct locations. Okay. The parentheses, you can do further customization with your code in the parentheses. Whether or not you actually want to go and put something in here is irrelevant, okay? Because this is what we call a method. This is a function called start, and there are some added things that we can go to. We'll get into what the parentheses are for in later videos. For now, though, you have to have them. If I do not include my parentheses, I get errors. And if I have errors in my code, and I try to hit play, I get this error, and the game doesn't work. One single error in your code, one misspelt word, one missed parentheses will prevent the game from running at all. Okay? Because the computer can't read it. It doesn't know what to do because it's not familiar with what your code says. It doesn't know what, okay. First curly bracket, and you'll notice that when my cursor is next to it, okay, you notice that it changes, it gets highlighted in a kind of grayish color, and then there's another one highlighted down here. This means that these are linked brackets. Anything in between these two brackets, so perhaps something written on line 9, that's the code that will run inside the start function. An acceptable method of having your opening bracket is to put it like this. The other acceptable method is like this. If you try to have weird stuff like that, other programmers, they'll be able to work around it, but they would consider your work sloppy and not up to standard, okay? So you can either choose a method that you like. I like it like this, okay? And of course, this bracket here now is the close. So everything that I want to happen at the very start, when I hit that play button, I need to write it all in between these two brackets. If this were a valid code, then it would run. Of course, it's not, because it's gobbledygook. Okay? At the start, well, let's write, no, we'll write code in just a moment, just a second. Let's just talk about these down here, okay? More double slashes, another node, okay? Okay, again, this is the, what is my, is there any data that we're going to get back from this? Void means no data, nothing like that. Just run the code, that's it. I don't know what you're doing, that's it. Just run it and don't give me anything else. Update, right? Update is called once per frame. This means that anything that is written in the update section, again, in between the two curly brackets, anything written here is going to occur once every frame. And in most games, that's either 30 or 60 frames per second. So void update, good for checking if certain conditions have been met. Like when it comes to pushing a button to open a door, right? This code would check every frame 30 times or 60 times per second. Is the player meeting the conditions to do something? Like if you want to open the door, you have to get close enough to the door and then press X. So inside the update function, you can check, is the player in close enough to the door, and did the player push the X button to open the door? And update, right? And so by having it called every frame, we can check if those conditions are true. And then whenever the condition is true, or in this case, both of the conditions are true, then further code will be executed. Okay, we'll do some stuff with update in a moment. Let's go back to void start. Okay, and this is a very basic thing. You'll see this in many different Unity videos, and we're just gonna have our console, this, give us a greeting. That's all. Okay, and to do that, we want to type in debug log parentheses my name is Chef Diggity Dog. Chef Diggity Dog. That's me. Anyway. Oh, why is it squiggly? I need a semicolon. Okay. So what did we just do here? What is this code going to do? Okay. Let's break it down. Debug.log. Debug, this is a type of class for code that is very useful, right? As it says here, containing methods to ease debugging while developing game. So this is just useful for finding mistakes. Like, when you're in the early phases of building a game, there's going to be errors. You can use debug to help you find those mistakes. What are these errors? Like, why isn't the ball firing when I hit the button or whatever, right? Debug can help you with that. .log, right? It logs a message to the console, right? So that'll put a message down here. Okay, and then we have everything inside parentheses. This is what's going to be said inside the console. Now I have to have these quotation marks. These quotation marks indicate custom text to be written in the log. Okay, and then a semicolon here at the end means that that section of code is done. That's all. You must have a semicolon there. If you don't, you're gonna get an error, and it's telling you, hey, right down in my error screen, hey, you forgot to write a semicolon. So there we go. Okay, cool. Everything's yellow here. We gotta make sure we hit save. Okay, let's go back. Right. I'm in my console down here. I'm gonna hit clear on my, oh, okay. Unity cleared it for me. Good. All right. And now we're gonna hit play. Let's see what happens. And great. The console produces a message. My name is Chef Diggity Dog, and here's where that line of code came from. Here's why here's why it's there, right? So that's the message. My name is Chef Diggity Dog. Alrighty then. And you notice it's only there once, right? Okay. And if I hit clear, it's not there anymore. Okay. We are currently in play mode. Now you're going to notice that your screen does not change color. I will show you how to make your screen change color in a little bit, okay? But for now, you know that you're in play mode because the play button appears slightly differently. If I were to go in and change this code and then hit save, it's not going to apply until I stop playing and then go back into play mode, okay? So whenever you are done testing a line of code, and then perhaps maybe you found a mistake and you want to go back and fix it and then test it again, always make sure you get yourself out of play mode. Okay? Now, I had you guys delete your main camera. Okay? So I will do that as well. And when I hit play, perhaps this is what you see. That's fine. Don't worry about it. We care about right now this console down here. This is what we're concerned with. Okay. All right, cool. Let us go back into the code. Okay. Well, we put all of this in void start. Let's see what happens if we put it in update. I'm going to cut it, and I'm going to paste it in the update method, the update function. So now every frame that's between 30 and 60 times per second, you should see this pop up down here. If you want to clear out your log, by the way, just hit the clear button. You can also toggle on clear on play. And so every time you hit the play button, it'll clear the log and then start fresh. I like to have clear on play, but sometimes you don't want that, depending on what you're doing or if you want to keep a track of everything. So, use clear on play at your own risk. Okay. All right. Oh, it's yellow. We got to make sure we hit save. Good. Okay. And let's hit play. No cameras. Whoa, your console is acting crazy. That's because every frame it is adding the message that, hello, my name is blah. Okay. You'll notice over here, we get, these are all the messages. So there's 999 and they keep adding and eventually it just stops adding them. Okay. I can hide those messages if I want to by clicking on this button. Okay. These are messages. These are warnings. And these are any potential reasons why your game does not work properly. or any potential things that are preventing your code from continuing. Like your code has hit a roadblock and it cannot go any further because of it. So, and then of course you can have it show messages, warnings, and roadblocks, and customize that and show what what do you want to see? Do you want to see your messages? No, I don't care about my messages. I just want to see the warnings and roadblocks, whatever. Okay, let's go here. Okay, so we have all of these messages, and they just keep adding. And you can see they just keep adding them. Right, there's just adding more and more and more. If I use the collapse button, whoa, they all went away. No, they didn't. There are over 5,200 messages coming through. What's happening is instead of repeating the same message a billion times, when you hit collapse, it's just going to put, this message is here, and this is how many times it's popping up. It's up to 6,200 messages now. If I hit collapse again, we'll see each individual message as it is there, okay? And if I hit and this is on update, so if I hit clear and erase all the messages, the counter resets, but because it's updating once every frame, that's 30 to 60 times per second, we're going to keep getting these messages. Okay, let's go to error pause. Well, these aren't errors, so they're not going to pause. Let's come out of play mode, and let's clear all of that. Okay, cool. Okay, we're going to get rid of debug.log. My name is Chef Daily Dog. Bye-bye. Alrighty then. Cool, make sure we hit save. All right. Well, that's communicating with the console. I'm not going to end it here. I could end it right now, but I'm going to keep going for you. All right. Well, let's actually get our console to respond to player input. We're going to get it to respond when the player does something. All right. So we're going to create an if statement. An if statement means that the code will only run if certain conditions are met. Okay? And we want it to be, if I hit the space key, that will make my console display the message that we want to see. Okay? So what we need the if statement, and we need to now what are the conditions of the if statement? Here they are. Input. That means something has happened. The player has done something. We've pushed a button, we've moved the mouse, whatever. Okay? If input, okay, dot get key, I'm going to say up. If input dot get key up. Okay? Now, how do we want to respond when the key up? Like what are we actually looking for? I can't just write the word space. Okay? That's not going to do it. I get the squiggly red line, meaning an error has been given out. And if I use a capital S, that's not what they're looking for. Okay? What we need are key codes. Get key up, parentheses, key code, dot, that's not it, key code, space, here we go. Good, okay. Key code, right, each key on the computer has a code. And for the space part, it's lo and behold, space. Okay. So what's going to happen if we hit the space key? Well, I'm going to do a new line. We want to open up a curly bracket. Now, anything that happens in these curly brackets, right? This line of code will only run if you hit the space key. Now let's do the exact same. Let's keep talking to the console here, okay? Debug .log. I'm going to say chef dog has hit the space key. Cool. Squiggly line. Remember, you've got to have a semicolon at the end to indicate that the code is done. And that's all. Yellow bars. Make sure you save. All right. So, void update is going to check every single frame if the space key has been pressed. Sorry, key up. This means that if this space key not necessarily has been pressed, but if the space key has been pushed and then released. Okay? If I hit get key down, that's different. So this one is looking for if you push the space key. And that's different than pushing the space key and then releasing it. Because you might notice that there are some games, it's like, hold down the space key to charge up your attack and then release the space key to fire it. Well, that's two different lines of code. One of them is, did you push the space key down? The other line of code is looking for, have you released the space key? So they're different. So let's go with up for the time being. Okay, get key up. This means that the button has been released. Okay, and we're checking for a certain code here. We're looking for the space key here. Okay, good. Debug.log, chefdog has hit the space key. You can have the message be whatever you want. Because of these quotation marks, you can write anything. You can write gobbledygook if you want. Okay, I can write doesn't matter. Unity doesn't care because we're in these quotations, so we can really write whatever we want it to say. We're not going to get any errors. Okay. Again, we've made changes, so let's make sure we save. Any yellow bars means you got to make saves. Okay. Cool. Let's try it. Hit play. And nothing's happening in the console. Well, duh. We haven't hit the space key yet. Hit that space key. Push it down. There's still nothing happening. Release it. Haha, there it is. Chefdog has hit the space key. Okay, let's try it again. Release, push, release, push, release. See? Okay. Now, you might think, dude, I want to make a game, man. Okay. Making a game is a very complicated process. And this message here is really good because now I know that the computer knows that I hit the space key. And that's really helpful for me if I want the space key to mean something. If hitting space means, or better yet, if releasing the space key means some kind of functionality is going to happen, like that's how you jump, well, then I want to make sure that my computer knows that I've hit the space key. I want to make sure Unity knows what I'm trying to do. Okay? And when I see this message, I know that something has happened. I know that line of, the line of code above this has run accurately. Okay? And we'll get back, and we're going to be using debug quite a few times. Like when we get our character to start walking, we're going to have it debug tell us that, the key has been pushed, the character is walking. All right. So that's the introduction to C#. Please look out for the next video, and I will show you how to use C# to make a character like this guy move around. I will also show you how to make this very simple character. There's literally two parts to him. Anyway, but just a quick recap. We went over some of the things about the Visual Studio environment, went over notes, went over the importance of the curly brackets, and we went over the importance of spelling and punctuating everything perfectly. Because if you don't, you'll either get an error, or probably worse, you'll accidentally write a different type of code that makes your game do something totally different than you intended, right? But the computer doesn't know what you intend on doing. The computer is only going to do what you tell it to do. Even if you make a mistake and tell it to do the wrong thing, the computer doesn't know that. Okay? If it all sounds very overwhelming and confusing, good. That means you're doing it right. Okay? You can't tell you how frustrated I got getting this little guy to move and getting him to pick things up, getting him to drop things, and getting the mission to work. And it was very frustrating. And I was about to rip my hair out. Okay. That's it. I will put up another video soon. Ciao.